All right, so I believe that every one of you had a great break, although there was an assessment. So I also believe that the assessment is almost finished by now. So and the I also believe that the YouTube videos help you to understand the questions. Question three is quite a difficult one. I'm pretty sure that's why there was a long video. And so today I'm going to talk about another topic, which is timber. And this week we take our lectures and tutorials quite differently. Typically, what we do is we teach the content, the required content in the class, and then we do a practical exercise in the tutorial. But there's a bit of discontinuity in this week's lecture and tutorial, because in the lecture I think this way will be better. In the lecture we teach about timber and timber boards, and we talk about material aspects only. But in the tutorial class, we talk about construction aspects, that is when we use timber in actual construction. So we have a slab on ground construction as well as a suspended floor that is constructed using timber. So actually when the although the tutorial is on construction aspects, in the lecture we do not talk about construction aspects, but the required knowledge to carry out the tutorial we will talk during the tutorial session. As I said before, considering that the nature of tutorial, as well as considering that you will be busy during this week to complete your assessment, we will not have regular classes for tutorial. What I will do is I will publish a pre-recorded video in form of a YouTube video, and on Friday we will have a question and answer session. So I can go through the video before. So if you have questions, I can answer during this question and answer session. And that's how we do module 7. Sorry about this part B, and it's not intended, because in the last year there were two parts. We talk about staircases and timber in the same week, but it was too much. That's why it was separated this time. But I forgot to just remove this from the title. And let's move here. And this lecture also divided into two parts, because we have timber and timber boards. So in part 1 we are going to talk about timber as construction material, and then in part 2 I'm going to talk about timber boards as construction material. So in this part, in part 1, we are going to talk about features of timber and how to recognize a good timber, piece of good timber, and some properties like density, fire resistance, and moisture content, and how they influence towards design and construction. And timber is a widely used construction material, especially in the eastern states of Australia. There are several advantages when it comes to timber. It's a sustainable material because we can grow forests, and waste management is sustainable also, and easy to work with, as well as availability wise is widely available. And some people have special preference to go with timber construction because of its aesthetic value. And so we already know what is strength to weight ratio. That means strength divided by weight. If you consider about a structural member, if the strength to weight ratio is high, that means we can have lighter sections to bear up load. So it's a good feature. Although it says timber has a great strength to weight ratio, actually to talk about strength to weight ratio, we need to compare different types of materials like concrete, timber, steel. At the moment, we know only about concrete only, so I'm not doing a comparison at this moment. But at the later stage of your course, especially in semester 2, I think in high-rise construction, we will compare different types of materials in terms of strength to weight ratio. For example, timber versus concrete versus and steel. But if you compare concrete and timber, timber has a greater strength to weight ratio, which is a good thing. And embodied energy also another consideration when it comes to sustainability. The meaning of embodied energy is from the point of taking raw materials and then up to the installment on sites, we have to spend some form of energy to make construction elements from the raw materials to the end product. That's total energy we call as the embodied energy. Okay, when we consider about timber, the embodied energy is very low compared to concrete and steel. So that is a good thing about timber also. So if we can move towards timber construction, that is actually a great solution. That's why some countries like in Europe at the moment, they are talking about how to use timber in high-rise construction also, which is actually in Australia, we haven't gone up to that level. So when we use timber in high-rise construction, we have to engineer the timber sections also. And but in Europe, if you do some research, it's a quite interesting area. The main reason for moving towards high-rise timber construction is actually sustainability, mainly. If we consider about steel, steel is a good material for high-rise construction also because it has a very high strength to weight ratio. But when you consider the embodied energy, steel has a very high embodied energy. So in terms of sustainability, environmental sustainability is not a good thing. Okay. So just a bit of a general discussion about timber. So when we take a tree, we have two types of timber, and that's called sapwood and hardwood, and also we have bark. It's quite obvious that we don't use bark for construction, but we may use both sapwood and hardwood. The sapwood is the living part at the immature zone of a tree. It's important for to have sapwood. That's because that's the part that take water and nutrients to the tree to keep it going. But when it comes to construction, hardwood is more preferable, and this is the mature part of the tree, and it doesn't have living cells. It doesn't mean that it is dead. It doesn't have living cells. It's a matured one. And if you consider about a certain species, both sapwood and hardwood are equally strong. So it's a misconception that hardwood is stronger than sapwood. But there are other considerations that we try to avoid sapwood in construction. For example, since it has living cells, it has higher tendency to get attacked by insects. And fungi growth also is another problem associated with sapwood. And the natural decay resistance is very low also in terms of sapwood. So considering that, hardwood is more preferable as well as in terms of weight also. Although they are equally strong and weight about same equivalent moisture content, if you consider about sapwood, it has much higher moisture content. Okay, so basically they are heavier unless we allow them to dry out. So considering that as a conclusion, we can say that although sapwood and hardwood are equally strong, so we prefer to have hardwood because of other reasons like their durability, okay, and less susceptible for insect attacks, so which is a good thing. And if you consider a tree, and there are some trees that we can get good timber, and there are some trees we cannot get good timber. So some basic characteristic for recognizing a good timber is free of sap. We know why it is better not to have sap now, because in the previous slide I explained that. and uniform color is a great thing also. And also when you struck two pieces of timber, if you get a ringing sound, it's a good thing also. Okay, if you hear a dull sound, that's an indication that okay, there is a decay inside, so which is not good in terms of durability. And if you consider this image in the right hand side, the bottom one and the top one, if you compare, you see that in the bottom one and the top and bottom one both has rings, but their arrangement is different. And so we call them as annual rings because they represent a period of growth for a tree also. If they are narrow and regular, that means that it's a good piece of timber. If you consider the top one, you see that they are wider and they are not regular also. That means with compared to the bottom one, the top one is actually not that good. Okay, if we have regular and narrow rings, it means that the timber is good, okay, in terms of strength. And when sawed into timber planks, if we have a smooth surface, it's a good thing also. And we don't want to have knots, too many knots also, because it's an indication of bad timber too. Shakes means sometimes you see that if you take a timber piece, there are splits, long split along the timber piece, so they are called as shakes. If you have splits also, so it's not a good thing also. So that's how we recognize, separate, distinguish a good timber from bad timber. Okay. Usually, as you may not deal with this during the manufacturing stage, but when it is when the piece of timber is taken to the site, you need to know how to recognize bad timber, because we should not use them in construction. So another is, this seems like it's quite similar, but it's different. So in the previously we talk about sapwood versus hardwood. So we talk about the same species in that case. If you take any kind of a tree, you can see both sapwood and hardwood. But if you consider about species, there are different species of trees. So they can be divided into two categories called softwood and hardwood. Okay. So previously we talked about sapwood versus hardwood, but in this case, this is softwood versus hardwood. That's totally a different thing. This is typical. This is decided. The category is decided by species in this case, softwood or hardwood. So if you consider about in WA, some of the widely used timber for construction is Jarrah and pines also. You see that they belong to two different categories. And hardwood is stronger. Generally, most of the time, hardwood is stronger. So if it is a structural application, we try to go for this kind of species which belongs to hardwood category: Jarrah, balsa, teak, oak, mahogany. But the downside of hardwood is more expensive. So if we have general door frames, window frames, and furniture, that not high quality furniture, but normal furniture, we try to go with softwood because they don't need to be stronger, and because they don't work as structural members. So that's how we select timber for different applications. Typically, another advantage of softwood is they grow faster. And if you consider about hardwood, they take so long to grow. So if we can make more and more elements from softwood, actually is good in terms of sustainability, because we can grow and cut trees and we can replant and we can get the harvest faster. But when it comes to structural application, although they grow slower, we have to go for hardwood like flooring, and also sometimes girders that bear up loads. So in that case, we need to go for hardwood, although they grow slower. Weight wise, yeah, most of the time softwood is lighter, but there are exceptions also. For example, if you consider about balsa, the balsa is more lighter than most of softwood also. Okay, so in that case, in terms of weight, there are exceptions. So the outcome of this, so it's very important to understand what are the typically softwood and hardwood categories for what is the category that most commonly used timber species belong to. So have general understanding about some examples for softwoods as well as hardwoods. Again, if you have a question or if you cannot hear me or whatever the reason, so what you have to do is just raise your hand as I explained before. Because I can't hear you, I have switched. Or otherwise, what you can do is you can send me a chat message. Okay, if you have any question. And so let's talk. That is the basic introduction about type of timber. And then we will talk about some properties of timber and why it is important. Density is one of the most important properties of timber. There's a particular standard that when timber density is given, it should be given at a moisture content of 12%. Okay, so not like concrete, timber absorbs moisture and subjected to drying also during dry periods. So it's important to have a standard moisture content. When we provide density, then we can provide a comparison. Higher density is always good, although it means the is heavier, higher density, but it's stronger and stiff also. The difference between strength and stiffness, I don't know whether I have explained or not. Strength is resistance to loads, so it's a structural, so failure thing. Stiffness means resistance to deformation, deflection. Okay, so that's the difference between them. Hardness means when you scratch two materials, the material with lower hardness is subjected to scratches. Okay, so you already know, I'm pretty sure you know that diamond is the hardest material in the universe, also in the on earth also. Basically hardness means is a resistance to scratches and abrasion. So if the density is higher, the hardness is higher also, which is another good thing. And fire resistance wise and higher density will lead to better fire resistance also. In Australia, we have bushfire resistant timber that we should use for construction in bushfire zones. So these are the we normally call as BRT. So those are the BRT timber, and all of them have higher density relative to other timber species. So basically higher density is a good indicator of strength, hardness and fire resistance. So it's a good thing. But in terms of weight, yeah, the building can become heavier too. Most of the time timber properties we talk with reference to moisture content, including density. Because of that, it is important to understand how to measure moisture content. So what we will do is we take a piece of timber and we take wet weight. Okay. Then what we will do is we oven dry until the timber pieces is dry. Then we get the dry weight. So then by using this equation, we can calculate the moisture content of timber. If the moisture content is higher than 15%, we call them as unseasoned. This is wrong here. Okay, it should be the other way around. So when we calculate the moisture content, if it is higher than 15%, we call them as unseasoned timber. So if it is lower than 15%, we call that as seasoned timber. And so to make moisture content lower, so make from unseasoned to seasoned, we have to dry timber. So we can use air drying, which is called air seasoning, or clean drying also, then we call clean seasoning also. So the advantage of using seasoned timber is because it has a lower moisture content, the dimensions are not subjected to changes, much changes. Because otherwise, if you use seasoned timber, unseasoned timber, the moisture will be evaporated eventually. Okay, and then what will happen is the timber piece will be subjected to shrinkage, so which is not good. And also, moisture does not add strength, but it adds a weight. So this is not a good thing also. If we can remove the moisture content, that means we can reduce the weight of the construction element. So it's good in overall for the building. And also strength and hardness are improved too with reduced moisture content, but we have to be careful. So this strength and hardness is actually, it is optimum at 10% of moisture content. When we reduce moisture content further, that becomes timber become brittle. That means they fail suddenly. So we talk about ductility when it comes to steel reinforcement. Ductility means it can go large deformation before it is subjected to failure. So the opposite of ductility is brittle. That means it will not go under deformation before failure. When the load capacity is reached, it will suddenly fail without warning. So which is not a good thing. Okay. And so that's about the moisture content. So if we consider about different construction materials and based on the species group also, there is a particular moisture content that they should be within. So for example, if you use hardwood and for decking, the moisture content should be between 10% and 18%. Okay. So if it is around 10%, it's better because then it will not be subjected to shrinkage, much shrinkage also, and volume changes. And shrinkage, as I said, because of drying, we talk about shrinkage in detail when it comes to concrete. And in timber also we have shrinkage because of moisture changes. As I said before, if we use seasoned timber, shrinkage is not a big problem. But if we use unseasoned, because it has a high moisture content, the shrinkage is significant, so which will be a big problem. Although even though we use seasoned timber, we can see small dimensional changes in timber, such as shrinkage and swelling during wet seasons, but that doesn't cause much problems in seasoned timber. So the basic cause of volume change in timber is the moisture. So what we try to do is, because this actually shrinkage is only one side, so other side the timber could be subject to swelling if it absorbs moisture too. So to minimize both sides, what we typically do is we install timber at the moisture content midway between extremes. So example, if you have the highest moisture content in a certain area, imagine that the highest moisture content is 20 and the lowest moisture content is 10 if you consider about annual variation. So it's better to have it install it around 15, so the swelling and shrinkage will be in that way we can have an optimum solution for both sides. When we talk about shrinkage in timber, we talk about three different shrinkage values. Longitudinal, that's along the longitudinal axis, which is length, and then in the radial direction, as well as the tangential. Tangential means the perimeter. Okay. And so the minimal shrinkage is you always longitudinal, but if you consider the tangential is the highest shrinkage usually. Okay. So always it is important for us to understand I will answer that question a bit later, Blair. Thank you very much. And timber strength grades. So since timber, we use it as a structural material. In our exercise also we talk about timber as structural material. So for structural applications, strength is important. Timber strength can be given in many terms, like strength class in terms of bending and direct compression, direct tension likewise. But timber actually strength is not only decided by the species. If you consider about timber, if you consider about several pieces of timber from the same species, same tree, okay, still they can have different strength values because of individual variations. So it's impossible for strength for timber to provide the strength grade according to the species only. So there is a different grading system for timber to find out working stress and stiffness value. So for that, one of the method includes visual grading. That means you see this table here, table 3 here. If you consider the strength group, okay, if you consider this table, actually structural grade is determined by stress grade is decided by two different parameters, structural grade as well as strength group. Strength group is dependent of the species. So for different species, we have different strength groups. And then a qualified person, what we'll do is they will examine each timber piece and they will grade them from 1 to 5 according to the amount of defects within the individual piece. Considering that someone qualified person will visually grade each individual piece, although they belong to the same species. It doesn't matter in this case. This is a visual grading for each individual species. So people, what they do is each timber piece, they take it and visually grade them from 1 to 5 and separate them. You see that structural grade 5 is not given here because we don't use that. But if you consider about other grades, for example, imagine if we have a particular timber species belong to S3, and one piece could be F17, or another piece could be F14, and another one piece could be F11 according to the visual grading. F17 mean the basic working stress under bending is 17 megapascal. Okay, you should be familiar with megapascal by now because in concrete we discuss about strength in megapascal and steel reinforcement also. Likewise in timber we determine working stress in megapascal, but in this case we have a different system. The stress grade is decided based on both the type of species as well as the visual grading by a qualified person on individual basis. Okay, so let's see how we can see this through an example. So it says James is a qualified timber grader. After examining a piece of seasoned Jarrah, so now we know that Jarrah is the species, but still that piece could belong from 1 to 5. So then he classified it under the structural grade 3. So using the table, what is the basic working stress of timber piece in bending? Okay. So another type of information is given here because you need to know what is the strength group of Jarrah. And so you see that green and dry, they have two Jarrah densities, S4 and SD4. Green mean unseasoned, dry means seasoned. So in this case is seasoned Jarrah. So the strength group is then SD4. Okay, let's go back here. Where is SD4? SD4 is here. Then it says visually it is subjected to structural gate 3. So from this one, horizontally we see this one, and vertically we come with N4. So the structural gate is F14. That means the basic bending stress is 14 megapascal under bending. Okay, that's how we decide the strength of timber. There is machine grading also. I do not talk about machine grading, but you can do some research rather than visually examining by a qualified person. So that's called visually examining visual grading. We can do machine grading also, but visual grading is more widely used in Australia. Yeah, green was unseasoned. Okay, thank you for that question. Green mean unseasoned, dry mean season. Okay, season mean less moisture, so you can it's mean dry. Okay, is it good, Steven? Blair, I'm going to answer your question. So when a timber is treated, does that affect the moisture content? Uh, this is what we do. We treat timber in order to minimize moisture absorption. I will put that in that way. Okay, so we can treat moisture to reduce the absorption of moisture. Is that what you expected, Blair? Hello. Okay, I will type his answer. Okay. So to influence the moisture content, what we will do is to reduce the moisture content according to certain limit, we need to do seasoning or air seasoning or clean seasoning. That's how we reduce the amount of moisture content. After that, what we can do is we can apply chemicals to reduce the moisture absorption. Okay, I don't know whether I answered your question or not. Okay, yeah, so basically to reduce the moisture content, what we need to do is we need to do air seasoning or clean seasoning. All right. Okay, so fire resistance wise, it's quite. We think that actually timber is bad in terms of fire resistance. Yes, it catches fire, but what will happen is after it catches fire, actually it forms a protective layer around timber piece. Okay, so inside they will not be subjected to burning. This doesn't mean that it's totally safe from fire, not at all, because it catches fire. But timber is better than untreated steel in terms of the fire resistance, because what will happen is steel will reduce like within 15-20 minutes it will reduce its strength by probably by 40% or 50% within 15 to 20 minutes when it is exposed to fire. So suddenly, although it doesn't get burned, still, because of strength reduction, the structure will be subjected to collapsing. But in terms of timber, it will survive for longer because the inside will not be subjected to burning because of this protective layer. Okay, but it's not the end of the story for steel, because when we use steel for construction, usually always we need to provide protective layers, so it will enhance the fire resistance up to hours. We don't know about steel, how to do fire protection for steel now, but we will talk about that in high-rise construction. Okay, but if we compare untreated steel, unprotected steel, so with compared to unprotected steel, timber has a higher fire resistance. Okay, still it catches fire. All right, that's all about timber. Now I'm going to talk about timber boards. So in terms of timber boards, there are different types, and I have given different types of boards. Actually, some of them are not timber. We will talk about some of them under high-rise construction. Just to give a list here, I have included all of them, but today I'm going to talk about only timber boards, which mean plywood, particle boards, MDF, and block boards. I'm not going to talk about anything today. Before I assume that there are no questions from timber before I proceed to timber boards, but if you have a question anytime, you can just drop a question, please. So timber boards are available in predefined sizes, and usually there is a veneer or laminated face because otherwise timber boards, they don't have a good appearance. And if you consider about strength, actually it varies, and weaker ones we use for thermal and sound insulation, which is a good thing. But if it is stronger, we can use them for certain type of load bearing application like flooring. Doesn't bear up too much load, but still it has to bear up the load on top of the wall for a small area. So for that kind of application, we use these stronger parts. And also fire resistance vary, and so since it is made out of timber, it catches fire, but we can enhance fire resistance by adding non-combustible materials such as fibrous cement. Okay, so considering that, if you consider about commercially available timber boards, they may have a particular type of fire rating that you can find in product information sheets. The second problem with one of the major problems with timber boards is absorption of water, so that can lead to damages. So to avoid that, what we will do is we apply a coat, epoxy coating. So in that way, we can minimize, we can enhance waterproofness of timber boards too. Sorry that when I put the PowerPoint slides into Blackboard, not Blackboard, Collaborate Ultra, the pictures are subject to distortion. But if you refer to the PowerPoint presentation I have uploaded in Blackboard, it will not be like this. I'm sorry about that, and I think I should convert this into a PDF before I put it in here. I will do that next time. So let's talk about age. So these are common properties, and then talk about each type. As I said, I'm going to talk about 4 types of timber: plywood, blockwood, and particle boards, and MDF. If you consider about plywood, probably widely we use them. And when we manufacture plywood, what we will do is we have layers of thin layers of timber. It could be softwood or hardwood. Then what we will do is those thin layers we will glue together. Okay. And so to increase the strength, what we can do is we can add more layers. When we add more layers, that means thickness is higher and they become stronger. So another thing what we can do is when we consider about timber, we have a direction of grains. If you see this figure at the top, right hand corner, you see that there are grains. So grain directions. So for each timber, when we have layers, they have grain direction. What we can do is when we combine thin layers together to form plywood, we can alternate the direction of the grains. So in that way, we can increase the strength rather than adding more layers. So what we can do is, probably what we can do is we can do both, adding more layers and changing the direction of grains. Also, in that way, we can get a better, stronger plywood. Typical size 2440 and 1220. In terms of length and width wise, thickness will vary because based on the we usually use plywood for concrete formwork also, and based on the load bearing capacity, required load bearing capacity, we need to have varied thicknesses. And so we have gradings of plywoods also. According to the moisture resistance, we classify them as exterior and interior grade also. So exterior grade is manufactured with water resistant adhesives. So because of that, they are good for outdoor construction. Interior grade cannot be used for outdoor constructions because it doesn't have moisture resistance. And another grade is marine grade, and actually it's like a enhanced version of exterior grade. Marine grade is very good when we do formwork, especially when we want to reuse them several times. So because marine grade has even greater resistance to moisture. Okay. And that is according to moisture resistance, as well as for considering load bearing. We have two types also, structural and non-structural. Okay, so marine grade is definitely with added moisture resistance and structural, and so we can use them for formwork. Exterior grade is also suitable. Blair is a question which is a very good question, as it is made with a similar process. Is a LVL beam considered a structural plywood? No, LVL beam is a different process because it's LVL beam have a section. So we engineer them the LVL beam not only with the layers. Yes, it is made out of layers also, but we need to talk about sectional properties when it comes to LVL beam also. We will talk about that under roof construction. Okay, which is a very good question, Blair. Thank you. And but definitely LVL is considered as a structural plywood. Okay. And also, it's not about plywood timber type that we use for plywood construction. And as I said, it's thin layers, several thin layers are glued together. And so the durability and strength is determined by adhesives used for in the gluing process also. We have four types of glues, type A, B, C, and D. You see that if we want to use exterior and structural grade applications, so the glue type should be definitely A. Okay. And type B can be used also, but less permanence than type A. So concrete formwork we can use, but if it is a permanent one, like if we want to use plywood for permanent decking, for example, then we will not use type B. Type C and D we don't use for structural and exterior ones because they are not very good in terms of waterproofness as well as durability and strength. So that's all about plywood. So it's important to understand different grades, exterior, interior, and marine grade, as well as structural and non-structural applications, as well as the effect of glue types. Then we have another application called blockwood. In blockwood, we don't have layers. What we have is actually strips. So in blockboard, we have a core, which is made out of strips of timber, pieces of timber, then layers. Then what we have is we have two faces we call as veneer. So the purpose of veneer is actually to make good appearance, especially. And there may be different names we used for blockboards and in the industry based on the size of these strips. If they are a more than 80 millimeter width, we call batten boards. And if they are less than 7 millimeter, we call lamin boards. There may be several names. And so you can search for those names if you are interested. So they need adhesives also. So typically when we make blockboards, we use type D. So if you go back here, now we know that if it is type D, we can't use then for exterior applications. Okay, only for interior applications. Then that's all about block boards. So after that, we can talk about particle boards. Actually, when we saw wood, we have wood particles, that is the byproduct. So what we will do is we bond them together under high pressure and heat, that is particle boards. Okay, and typically this is the particle board shape, particle board, but we cover cover the board with veneer faces, as I said before, to enhance appearance. I'm pretty sure that it will reduce moisture absorption to some extent too. So the strength increase if we enhance density, which is a common relationship in any material. When we increase density, strength will be subjected to enhancement also. But particle boards, they don't have a higher bending and shear strength. Okay. On the other hand, they can be subjected to attack by moisture, insects, fungi, and fire also. But you see that we can apply preservatives to enhance, to minimize these effects also. Okay. For example, if you consider about moisture, if you consider a normal board, here is a problem, but you can also buy moisture restraint boards if you want to use in a high moisture content. Okay. Lastly, we have MDF, medium density fiber boards. So it's actually, I can say that this is an enhancement of particle boards. We use wood fibers also, but compared to particle boards, they are denser, stiffness is higher. Since it doesn't have, we use particles for boards, so in that sense we do not have knots in boards also. Yeah, moisture tolerance is enhanced with compared to particle boards, and the downside is we have health and safety issues with the use of MDF. And when people use MDF for construction, they have to use PPEs, appropriate PPEs. If someone is working on your site, if they work with MDF, then you have to make sure that required PPEs are used for eyes and the nose. So because of this chemical here. Okay. That's all about timber and timber boards. Actually, easy topic in terms of material. But when it comes to the construction topics, it could be a bit challenging. And but we will manage it in a better way this time, since we have a YouTube video tutorials. You can follow it at your own space. And today is Tuesday, so I will be able to publish that video by Thursday. So make sure that you keep few hours reserved to go through that on Thursday or Friday. But on Friday, when I schedule that questionnaire and answer session, I will schedule it for the afternoon. So still you have the morning hours to go through the tutorial before the questions and answers. I will publish the time slot quite later. Honestly speaking, I haven't done I haven't started the tutorial yet, but the tutorial is ready and I have prepared the answers, but I need to make the video yet. All right. So if you have any questions, it's the time to ask the questions. And so otherwise we can end the session here. So it's good that we have a quite light topic this week, considering that you still have to work on your assessment also. Okay, so I'm going to start a poll to see the let me check your experience. No, there is no tutorial today, Steven, so it will be pre-recorded. and available as a YouTube video. So then after you go through YouTube videos, we will have a question and answer session on Friday. Okay, I will tell you the time slot. I'm going to ask a question here, so then I can guess the quality of this recording. So please answer that question. Okay. Please answer the question. So based on that, Muhammad, yes, I will try. Okay. So he's asking, will YouTube video go into more details on team by strength grades? I didn't want to, but I think it's a good suggestion. So I will. Okay. Thank you. All right, guys. So I think the today's lecture went well in terms of clarity. So I will the video will be available later. So thank you very much, and I'm going to stop here. Blair, it doesn't matter whether you use hand-drawn sketches or use AutoCAD or Autodesk, because we typically want students to do hand drawing still, because they don't know how to do AutoCAD or Revit. But if you know how to do it, yeah, just do it. So there is no restrictions on, there are no limitations as long as the answer is correct. Okay. Yeah, if hand drawings are totally acceptable, and so, but you have reference to use computer aided design. Yeah, sure, you can combine too. Question number 4, Kenny. No, you don't need. It's just I provided that information. I think you are asking about the end condition, the how the wall is supported in question 4. Sorry, how the suspended flow is supported on the wall. No, you don't have to. Okay, I provided that details because then it's good to combine previous knowledge with the remaining this assessment. That's why I provided that knowledge, but you don't have to. Okay. Thank you. So I'm going to stop here. Thank you very much, guys. Keep safe.